Okay, so you've probably heard this term floating around, right? Three-parent babies. It grabs your attention because, honestly, it sounds like something straight out of a sci-fi movie.
And the headlines, wow, they run with it. It just conjures up these wild images of scientists in a lab fundamentally changing what it means to create a family. The name itself is designed to be sensational and, yeah, a little bit alarming.
But what's the real story here? Are we talking about a slippery slope towards genetically engineered designer babies? Or is this actually about giving hope to families who are facing just unimaginable heartbreak? Well, that's what we're going to unpack. We're going to separate the science from the science fiction. And first things first, we have got to talk about that name. Because three-parent baby isn't just a little inaccurate, it's a seriously misleading term that completely twists what this science is all about. So let's just get right down to the genetics. You see this chart, that huge slice, the 99.9%? That's your nuclear DNA. It comes from your mom and your dad, and it determines pretty much everything that makes you you, your hair color, your height, your personality, the whole shebang. Now, see that tiny, tiny little sliver, the 0.1%? That's the only part that comes from a donor. It's mitochondrial DNA, and its only job is to power the cells. It has nothing to do with personal traits. You know, I absolutely love this quote from Dr. Gillian Lockwood because it just nails it. This isn't about three parents, it's 2.001 parent IVF. That little fraction of a percent is a functional fix, not a parental one. It's just a brilliant way to think about it. So here's maybe a better analogy. Calling this a three-parent baby is kind of like calling someone who gets a kidney transplant a two-person individual. It just doesn't make any sense, right? A much, much more accurate way to see this is as a kind of transplant, just on a microscopic level. You're replacing a faulty part to keep the whole system running. Okay, so if it's not about making a three-parent baby, then why do it at all? Why is this procedure, which is actually called mitochondrial donation treatment, so incredibly important? Well, the answer gets to the very human reason this science was developed in the first place. Remember how we said mitochondria are the powerhouses of our cells? Well, when they don't work right, the parts of your body that need the most energy start to fail. We're talking about the brain, the heart, the liver, your muscles. This can cause this horrific cascade of problems, from muscle weakness and organ failure to really severe neurological issues. And tragically, for some kids, it can lead to things like sepsis or even sudden death. And this is the heartbreaking reality. For a baby diagnosed with a severe form of this before they're even 6 months old, it's very often a death sentence. So imagine you're a parent, and you know you carry this gene. For years, the choice has been just agonizing. Either risk passing on a fatal illness or don't have biological children at all. This technology offers a third way forward. All right, so let's get into the nitty-gritty. How does this technique actually work? We're going to look at the most common method, which is called pronuclear transfer. And just one more quick reminder, because it's so important, mitochondria are the cell's batteries. They just provide the juice. They do not determine who you are as a person. That distinction is absolutely key to understanding all of this. Okay, so here's the play-by-play. Step 1. The mother's egg, the one with the faulty mitochondria, is fertilized with the father's sperm. So now you have the parent's core DNA together. Step 2, you take a healthy egg from a donor and carefully remove its nucleus. All that's left are the healthy mitochondria. Step 3, you take the parent's nucleus and transfer it into that hollowed-out donor egg. What do you get? An embryo with all the genetic material from the parents, but now it's running on a healthy set of batteries. And finally, that new embryo is implanted just like in any other IVF procedure. Now, of course, a technology this powerful is going to raise some big ethical questions. A lot of them are fueled by that three-parent label we talked about. So let's actually unpack the main concerns and see what the reality is. Okay, so the big one you hear is germline modification. That means making a genetic change that can be passed down to future generations. And it's true, if the child born is a girl, she'll pass on the donor mitochondria. But the counter-argument is all about intent. The goal here isn't to enhance a person or add some special trait. It's simply to prevent a child from inheriting a terrible, often fatal disease. The change doesn't alter their fundamental identity. Then there's the classic slippery slope argument, that this is the first step towards designer babies. But the thing is, countries that have legalized this, like the UK and Australia, have put really strict rules in place. It can only be used to prevent serious mitochondrial disease. It's not a free-for-all. And as for the child's identity being confused, well, we've already covered that. That 0.1% genetic contribution from the donor is, for all intents and purposes, functionally invisible when it comes to who that person becomes. Now, to be clear, this doesn't mean it's totally risk-free.
there are real medical things to watch out for. For example, there's a small chance some of the mother's faulty mitochondria get carried over and start to multiply again. These are genuine challenges that scientists are working on, but they're seen as medical hurdles to overcome, not as fundamental ethical reasons to just stop everything.
So, with all this debate swirling around, how is the world actually handling this? Well, as you can probably guess, the approach is all over the map.
You've got the United Kingdom, which really led the charge. They legalized and regulated it way back in 2015 and have had at least 8 babies born since. Australia followed their model a few years later. Then, in a completely different camp, you have the United States, where it's effectively banned because of really broad laws about editing embryos. And for the rest of the world, it's a mixed bag. Some places have fewer rules, while others are just taking a cautious wait-and-see approach. So where does that leave us? What's the big takeaway here? I think it all comes down to choosing clarity over alarmism. The words we pick to talk about this stuff, they really, really matter. At the end of the day, this isn't about creating a third parent. It's about giving a family a chance to have a healthy child, a child who won't have to suffer from a horrible inherited disease. It's a medical intervention, and the focus should always be on that, on preventing suffering and, in many cases, saving a life. So I'll just leave you with this question to think about. When science comes up with a tool that can stop a lethal disease before it starts and gives families a new kind of hope, what's our responsibility in how we talk about it? What words should we choose?